Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss VLSI design flow. VLSI design flow. A typical design flow a typical a typical design flow for designing very large scale integration. Very large scale integrated very large scale integrated, that is nothing but VLSI, very large scale integrated IC circuit. Very large scale integrated circuits, IC circuits. Let us see the design flow. There is a design flow. the first one is the first one is we take design specifications. Design specifications. Design specification. The second one is design entry. Design entry. Design entry. And the next one is functional verification. Functional verification. Functional verification. And the next one logic synthesize. Logic synthesize. Logic synthesis. Next one, logic synthesis. And the next one, system partitioning. System partitioning. System partitioning. And the next one, floor planning. Floor planning. Floor planning. Then after floor planning, after floor planning, place and routing, place and routing, place and routing. Okay. After place and routing, we can check the timing simulation, timing simulation, timing simulation, timing simulation. Okay. Then after timing simulation, you can see physical verification. After timing simulation, then we can do the next flow, physical verification, physical verification, physical verification, right? Then after physical verification, it will be go under the test. So some continuous tests over the period of time. So it is a testing, testing. After the testing, the final one, over the period of time it will be tested. Then the finally it will be submitted to the chip fabrication. It will be submitted to the chip fabrication. Chip fabrication, bonding pads, input, output for input output pins, and checking for the package, different types of package selection. Chip fabrication. Chip fabrication. So this is a design flow of a VLSI circuit in industry, right? Let us go through. So a typical design flow for designing of a very large scale integrated IC circuits, right? First we should do the design specification. So design specification is nothing but choose a right technology path, choose a right technology. So knowing the requirement of a vendor. So what is a vendor's mind and what is the technology needed, so that if you specify the design specifications, so that we can reduce the time, and it can know the some specifications. So how many gates are using, okay, how many gates are using in the design specification, total cost, timing, all this we can represent in the design specifications. Next one, so let us first it will be design specifications, choose the right technology. Here I am writing right technology, choosing the right technology, choosing the right technology. Then after design entry is the design entry is nothing but two ways of design entry. One is schematic and schematic, and second one is a HDL entry. So schematic entry is nothing but a graphical representation. HDL entry, the programming, other text data, programming language we can represent of this design. Functional verification. So verify the logic of the function. Logic verification. Logic verification. Okay, logic. Whatever the design we are going to design, we can verify the logic of a design. We can verify the logic of a design. Logic synthesis means logic synthesis means all the logic blocks, logic cells, logic cells, netlist, netlist representation, netlist. Okay, netlist. It is a description of logic cells netlist, input output pins in detail information. System partitioning, the complex system into complex complex system to complex system to small small blocks. Complex system into small blocks. So this is a system partitioning. Floor planning means estimate the chip area. Estimate the chip area. So how much chip area required for all the logic blocks. So that is nothing but a floor planning. Estimate the chip area all for all the logic blocks. Right? Place and route. Place and route means specific no specific place is allotted. Place and route for the specific place and route for the place and route for all logic blocks. All logic blocks placed in a specific logic blocks, specific area. So specific area of specific area, place and route, all logic blocks. So this is about place and routing. So what about this timing simulation? Simulation is nothing but so describe the timing analysis, time delays, knowing the time delay. So how much time delays of logic cells, logic cells and interconnections, right? Physical verification. So after time and all verifying that, then we can verify the physical verification. So physical verification is nothing but rules and electrical design rules, electrical rules, electrical rules and electrical rules and DRC design verification rules, design rules, design rules checking, right? These are the physical verification. Electrical rules means signal flow, how the signal flow in a circuit, that will be verified by electrical rules or design rules. Testing is nothing but so after the physical verification, electrical signal rules and design rules, then it will be tested internally by the built-in self-test. Built-in self-test. Built-in self-test. Built-in self-test. So go through the built-in self-test. Built-in self-test continuous over the period of time. Continuous test. It is a continuous test. Continuous test over time. Over period of time. Over period of time. So after it will be verified the chip. So whether whenever it will going to produce, whenever it will going to chip fabrication and the product going to come, it will be testing some over period of time, and there is an internal built-in self-test. So chip fabrication before going to submit the fabrication chip fabrication, it will be verify the input output pads input output pads input output pads included, right? Input output pads included and packing and what is a plan of packing is verified. plan of packing plan of packing for input for pins, input output pins. So before going to submit the chip fabrication, it verifies the input output bonding pads included, and a plan of packing for pins. So the finally after this verifying, it will submit it to the fabrication. Then the product will come out. Right? Let us see. We can write what is a one by one step. The first one is The first one is design specifications. Design specifications, right? Design specifications. What is a design specification? Design specification is nothing but, right, and let me, previous page is there. Let me go and write in that. So first one, design specifications. Design specification. Design specification is nothing but, am I given information about that? Design specification is nothing but choose the choose the right technology. Right technology. Choose the right technology when we are going to design a specific product. When you are going to design any VLSI product, first we can choose the right technology. Right technology, knowing the requirement of a vendor, knowing the what is a requirement, so that can be known. Knowing the requirement of vendor. This is known by, it is known by a designer. A designer can known by what is the requirement of a vendor. What is the requirement of a vendor? Then he can choose, according to that he can choose the right technology. If you are choosing a right technology, then it can reduce the time. So it can reduce the time. It can reduce time, right? It can reduce time. If you choose the right path and what is a vendor requirement, all these keep in mind. The designer should take a decision according to the specifications, so that it can reduce time. The time will be reduced, then easily the product will come out. Okay, some specifications are like some specifications, right? Like, what is a timing of a product. So timing of gates which are using, timing of gates, total gates, how many total gates are using, how many total gates are using, and what is the power, total power required, how much time taken for the timing also required in a gate signal passing through, total power, how much total power, how much total cost, how much total cost, right? How many blocks are using, right? How many blocks, logic blocks, and cells, logic blocks, how many logic blocks, logic cells, right? These are the specifications of a basic specifications is taken by a designer. So it is a design specification first, right? Second one, right? Second one is design entry. Design entry. What is a design entry? So design, after knowing the specifications, so it should be entry. So design entry can be, so design entry can be chosen. Design entry chosen two ways. Okay, chosen two ways. One is schematic. One is schematic. Second one is HDL entry. HDL entry. In the schematic entry, graphical representation. It is a graphical representation of the design. Graphical representation of design. Representation. Representation of design. So it is a graphical representation of design. Okay, after specification, then it can be represent in an entry. So the entry level is a schematic representation and HDL representation. HDL representation is a text based entry, text based programming entry, programming language, text based programming language. Programming language, that is nothing but a hardware description language. Hardware description, hardware description language. So this is called HDL. This is called HDL. Now the third one is functional simulator or functional verification. Functional verification. So in the functional verification, we can verify the functionality of a design, verify logic of the functional, verify the verify logic of the design, verify logic of the design. So what is the logic of the design? It should be verified in a functional manner. Okay, verify logic of the design. Logic of the design. Logic of the design is verified, right? Means it is nothing but we can say it is a truth table verification. Truth table verification. Truth table verification. Truth table verification. When you are giving the input logic, so how it whether it will be working according to the design or not. If it will be adding or not. If it will be counting or not. So if adder adding or not, adding or not, and counter counting or not, counter, that is a functional verification. If it is a counter counting or not, so this is verified by a functional verification, right? Functional verification. Functionality of the design, logic is verified, like it is a truth table verification, adder adding or not, counter counting or not, right? What is the next one? It is third one, right? Fourth one fourth one is logic synthesis. Logic In the logic synthesis, so it produces the logic synthesizer, it produce netlist. It produce netlist. So it produce netlist of all netlist of all logic cells, all logic cells, all logic cells in detail, in detail, in detail information. Produce the netlist of logic cells in detail representation. So logic synthesizer gives or produce a netlist of all the logic cells in detail. That is called logic synthesizer, right? The fifth one, the fifth one. What is the fifth one? Fifth one is system partitioning. System partitioning. System partitioning. So the complex block into small blocks. So complex logic into, so system partitioning. After synthesize, produce logic cells in detail information, then it will be partitioning. Means it will be complex blocks into complex blocks into complex blocks into small blocks, small blocks. So complex blocks into small, each and every small blocks representation, dividing, separation. Okay, this is nothing but a system partitioning, right? The sixth one is a floor planning. Floor planning. What is a floor planning? Floor planning. After partitioning, after partitioning all the logic blocks, all the logic blocks, so we can estimate the, we can estimate the, estimate the, estimate the chip area, estimate the chip area, total chip area is called as a floor planning. Estimate the, estimate the total chip area. So how much total chip area is required for the logic blocks? Logic blocks. So that is a estimation. It is nothing but a floor planning. In the floor planning, we can estimate the total chip area. Estimate the total chip area. How much chip area is required? That is nothing but a chip area. Floor planning, right? Now the seventh one is place and place and route. Place and route. Okay, placement. So after chip area is allotted, the chip area is allotted for the complex blocks and logic area, complex blocks and into small blocks. Then we can place the logic blocks in a specific area. So allot a specific area, specific area, specific specific area for all logic blocks. So allotted specific area for all logic blocks, all the logic blocks. Okay, that is nothing but a place and route. The placement and routing. So allotted a place for logic blocks for a place and route. So specific area for all logic blocks for place and route. So routing is allotted, specific place is allotted for the logic blocks, place and route. So this is the seventh one in the designing process, right? Now what is the eighth one? Eighth one is a timing simulation. Timing simulation. Timing simulation. In the timing simulation, we can know the time delays of a logic blocks and interconnections. Okay, so we can specify, knowing the specification, knowing the time delays of, knowing the time delays, knowing the time delays of logic cells and interconnections. So it is a timing simulation. So knowing the time delays of all the logic cells and interconnections. Interconnection. How much time delay is taken? Logic cells and interconnections. Interconnections. This is all about timing simulation. Timing simulation means we can know the time delay, how much time taken whenever the signal processing after placing the logic blocks for routing. Now whenever the signal is applied, so how much the time simulator is knowing the time delays of logic cells and interconnections. The ninth one, after knowing the time delays, now there is a physical verification. Physical verification. Physical verification is nothing but verifying the electrical rules. Verifying the electrical rules physically. Now the signal flow. The electrical signal flow. So electrical signal verification. Electrical electrical signal verification. Right? Electrical signal verification. Electrical signal verification. Right? What happens in the physical verification? Physical verification is nothing but after time simulation logic blocks. Now electrical signal verifying the logic blocks and DRC check, design rules checking, DRC checking, DRC check. Okay, DRC check means design rules. So checking design rules, checking design rules, all the design rules, electrical signal passing so through the logic blocks. So it will be known by a physical verification. Checking design rules. So design rules, that is nothing but a physical verification, right? Now 10th one is a testing. After electrical signal verification and DRC checking the signal flow and all. Now testing. So testing is done over a period of time. It will be tested. Built-in self-test. It is a built-in self-test. Built-in self-test. Built-in self-test. It will be done built-in self-test. So continuously over a period of time. Continuously over a period of time. Over a period of time taken. Period of time. So before going to the submitting the fabrication and all the product design, it will be tested. It will be self testing continuously over the period of time. So it may be continuous verification whether it will be regular, it is continuing or failuring with the input signals. So that is a testing process. The last one, is chip fabrication. Chip fabrication, right? Chip fabrication. So chip fabrication, before going to submit fabrication, before going to submit fabrication, before going to before going to submit before going to submit fabrication, verify the verify the verify the bonding pads, verify the bonding pads, verify the bonding pads for input and output, for input and output, for input and output, for input and output, right? It should be verified before submitting all these requirements in a fabrication process. So it verify the bonding pads for input and output, and what is the plan for package, what is the packing. Okay, now after that fabrication, the packing is required. So plans for verify the plans for package. So verify the verify the packing plans, verify the packing plan, packing plan for input output pins, for input and output pins, input and output pins, input and output pins, right? After verification of all the things, after verification of all the things, then it will be submitted the fabrication according to the designer specification. It will be fabrication is done, then bonding pads and the packing plants for input output, then the product will come out, right? So please subscribe the channel, inform your friends, like this, okay? Then you can learn the subject very easily in this channel, right? Thank you.